Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay. A distant galaxy is moving away from us. Okay, dear students, away from us and towards us, two separate senses. Okay. A distant galaxy is moving away from us at speed 1.85 into 10 to power 7 meter per second. Calculate the fractional redshift lambda dash minus lambda naught over lambda naught of the light from this galaxy. Okay. Now we come to its solution, but before its solution in a proper manner, we discuss some snapshots which will make a foundation regarding solution of our problem. Okay, first snapshot is about Doppler effect. Okay, Doppler effect, electromagnetic waves, source approaching observer. F is equal to under root C plus U over C minus U into F naught, where F is the frequency measured by observer, F naught is the frequency measured in rest frame of source, U is the speed of source relative to observer, and C is the speed of light in vacuum. Okay. Another version of Doppler effect is given below. Okay, Doppler effect, source oblique observer approaching, F equal to 1 plus beta over 1 minus beta whole under root into F naught. Second form, source or observer receding, F equal to 1 minus beta over 1 plus beta whole under root into F naught. Dear students, here beta means speed parameter, that is V over C. Dear students, now these two cases have been taken separately. Okay, F is equal to 1 minus beta square under root over 1 minus beta into F naught. This becomes equal to under root 1 plus beta over 1 minus beta into F naught. This is case of approaching. Actually, dear students, because we know that A square minus B square is equal to A plus B into A minus B. Okay. Now we come to second case, which is receding. F is equal to 1 minus beta square over 1 plus beta into F naught. This becomes equal to 1 minus beta over 1 plus beta whole under root into F naught. This is the receding case. Okay. Now we come towards the speed parameter. Okay. If relative speed between frames is V, the contracted length L and the proper length L naught are related by L equal to L naught 1 minus beta square whole under root. This becomes equal to L naught over gamma, where beta equal to V over C is the speed parameter and gamma equal to 1 over 1 minus beta square is the Lorentz factor. Okay. So, using this Doppler effect, we start our problem in a regular form in this way. Okay, using F naught over F dash equal to 1 plus beta over 1 minus beta. Why we have chosen this form of Doppler effect? Because in statement it is given that moving away from us means receding, and receding case is this, in which 1 minus beta is upper and 1 plus beta is in the denominator. Okay. Actually, f naught over f dash, we will take this and this f will be, this f in terms of dash will be shifted below f dash, hence this factor will be shifted to other side of equality, and hence 1 minus, dear students, you are seeing that f naught over f dash equal to 1 plus beta over 1 minus beta. This is receding case, and in the receding case is this 1 minus beta is above and 1 plus beta is below. But here this is the situation of receding. The reason behind this is that here f naught over f, this f will be shifted on other side equality, and this factor will be shifted on other side of equality, and hence f naught over f dash will become 1 plus beta over 1 minus beta. We know that frequency is the reciprocal of wavelength with the involvement of speed of light, that is f naught is equal to c over lambda naught, and f dash is equal to c over lambda dash. Okay, so here now we can invert it, that is it can be written as c over lambda naught into lambda naught over c. Then c will be cancelled with c, and we will get lambda naught over lambda dash over lambda naught equal to 1 plus beta over 1 minus beta. Okay, just rearrangement. Okay, lambda dash over lambda naught is equal to 1 plus beta over 1 minus beta. Rearranging the fractional redshift as under, this is given lambda dash minus lambda naught over lambda naught. Okay, so lambda naught will become under this, and then lambda naught will become under this. Okay, lambda dash will be divided by lambda naught, then minus lambda naught will be divided by lambda naught. So it will take the form as lambda dash over lambda naught minus 1. Lambda dash over lambda naught, lambda dash over lambda naught minus 1. Okay, dear students, in the above portion we have calculated this lambda naught, lambda dash over lambda naught. Okay, this, its value is this. Okay, now we are putting this value here, so it becomes as, in place of lambda dash over lambda naught we have used this value. Okay, and then after putting this value, remaining is quite simplification. Okay, what we have done, we know that beta is a speed parameter which is equal to v over c, and v is given in the statement 1.85 into 10 raised to the power 7 meter per second, and c is a constant. Okay, we know that value of c is 2.998 into 10 raised to the power 8 meter per second. Okay, so nothing more, just we have put the value of beta, that is beta is speed parameter v over c. V is given in the statement and c is a constant speed of light. Okay, so quite simple. After simplification it will take this form as, okay, 1 plus 0.0617 over under root over 1 minus 0.0617 minus 1. Okay, this will become equal to 1.03 over 0.9686. Okay, because dear students, this will become 1.0617 under root, and it will become equal to this, while this value will be different. When we will subtract this factor from 1, something else will come, and then when we will take under root of that value, then that value will be equal to this value. Okay, minus 1, this is as it is coming along with. Okay, hence this factor will become equal to 1.063 minus 1, and hence our answer is 0.063. This is our required value of a redshift. Okay, this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.